you had seen this example before, where you're to find delta x by delta u, delta x by delta v, delta y by delta u, and delta y by delta v. If z is a function of x and y, u is e to the x cos y, and v is e to the negative x sin y. Now, we had looked at this previously, and we found these derivatives without using the Jacobian. Now, it was very difficult. It was a lengthy process and a lot of work. Alright? Now here, we're going to do it again, but this time we're going to use the Jacobian. Here, and of course I would expect that in any, if you're given this is in an exam to do, you'll be given a formula sheet, because these formulas are not very easy to remember. Alright? Now, the Jacobian. The Jacobian, as you remember, is a determinant. It is delta u by delta x, delta v by delta x, delta u by delta y, delta v by delta y. That's the Jacobian. And some results that we looked at in the previous video. Remember, we formulated the Jacobian and we looked at some results that came from the Jacobian. Alright? We found that delta x by delta u is equal to delta v by delta y divided by the Jacobian. We found that delta x by delta v is equal to negative delta u by delta y divided by the Jacobian. We found that delta y by delta u is equal to negative delta v by delta x divided by the Jacobian. And we also found that delta y by delta v is equal to delta u by delta x divided by the Jacobian. Alright? So these are quite a number of results that we have here. Now, given these formulas, you would be able to find these derivatives in a much shorter time than you did earlier. Now, here, you're given these two functions, u and v. What is the delta, what is it? We want delta u by delta x, as we have here. You see the delta u by delta x here. We need this. We need delta v by delta x. We need delta u by delta y, delta v by delta y. And then later on, we're going to find delta x by delta u. Notice you have it as the Jacobian delta u by delta x. But what you want is delta x by delta u. It's the inverse, alright? Now, delta u, let's work it out here. Delta u by delta x. What was it again? Remember, we did it before. It is e to the x cos y. Alright? Let's put it aside, put these things aside here. Then Let us find delta u by delta y. Or we could just find delta v by delta x. It is right beside it. Delta v by delta x is what? Looking at it, it's with the negative e to the negative x sine y. Negative. So let me rewrite this. Delta v by delta x is equal to negative e to the negative x sine y. Then we have delta u by delta y. Delta u by delta y, which we did before, or we're doing it again here. Delta u by delta y is equal to, notice, we have e to the x as a constant, because e is a constant and we're treating x as if it's a constant. So that remains e to the x time. When you differentiate cos, you get negative sine, so it's negative sine y. You see that? So delta u by delta y is negative e to the x sine y. Then after that, we want to find delta y. Oh, we want to find delta v by delta y. Delta v by delta y. In this case, delta v by delta y is equal to e to negative x cos y. Alright? So, these are the results that we're going to be using in the Jacobian. So now, let's work it out here. The Jacobian is equal to what? It's delta u by delta x, which is going to be e to the x cos y, and delta v by delta x, so it is negative e to negative x sine y, and we have delta u by delta y, which is negative e to the x sine y, and then delta v by delta y is e to the negative x cos y. Alright? So, the value of it then, remember your AD minus BC procedure, e to the x, e to the negative x cos y, which is cos squared y, minus, now here, what we have here are two negatives. I'm going to minus the two negatives. So we minus negative this by negative that, which gives a positive. So it's minus, it's not going to be a minus negative, it's minus or positive. So it is e to negative x times e to the x sine y by sine y is sine squared y. So the Jacobian, these two will amount to 1 e to the x times e to the negative x, right? E to the negative x is like 1 over e to the x. So it turns out to be e to the x divided by e to the x. So we have cos squared y minus, same thing happens to the e to the negative x times e to the x. They will amount to 1. Cos squared y times sine squared y. But using the double angle identity and the trig identity table, you will find that this is equal to cos 2y. So the Jacobian is cos 2y. Alright? Now, given that the Jacobian is the cosine of 2y, we need to find delta x by delta u, which is one of the results we want here. So delta x by delta u. Results now. Delta x by delta u is equal to delta v by delta y. What's delta v by delta y again? Is e to negative x cos y. Alright? So it is e to the negative x cos y divided by the Jacobian. Now, delta y by delta u, or delta x by delta v, let's do that one, delta x by delta v, which is the other one we want. Delta x by delta v is equal to, now it's negative delta u by delta y. So it's negative delta u by delta y. Well, what is delta u by delta y? It's negative e to the x sine y. Alright? So here, delta x by delta v is negative delta v by, which one am I doing? Delta x by delta v is negative delta u by delta y. Right, delta u by delta y. So it's negative e to the x sine y. So negative e to the x sine y over the Jacobian. We'll clean it up after. After that, what do we want next? We want the next result, delta y by delta u, and delta y by delta u. What did we get a while ago? Delta x by delta v is negative du delta u by delta y, u by delta y, negative e to the negative x sine y. Negative e to the negative x sine y. Okay, good. Then, next, we look for delta y's now, the two delta y's, delta y by delta u. So, delta y by delta u is equal to the negative delta v by delta x over the Jacobian. Negative delta v by delta x divided by the Jacobian. So this will be over the Jacobian. But what is delta v by delta x? Delta v by delta x. Alright. Delta v by delta x is negative e to the negative x sine y. So this is negative e to the negative x sine y. Negative e to negative x sine y. Right? So we have that. That's delta v by delta x. Right? And then after that, we want delta y by delta v. So delta y by delta v is equal to delta u by delta x over the Jacobian. Delta u by delta x divided by the Jacobian. But what is delta u by delta x? U by x is e to the x cos y. So this is e to the x cos y. E to the x cos y divided by the Jacobian. Alright. So we have the 4 that we want. So I have delta x by delta u. Now, the Jacobian is, what was it again? It's cos 2y. So let us change all of these to cos 2y. Cos 2y. This Jacobian is cos 2y. But minus negative, we give you a positive, alright? So you see that? Now, the minus negative here again, give you a positive. And this Jacobian is cos 2y. This is over cos 2y. And then, of course, right here, this is over cos 2y. Alright? So what we have? are the four results. Delta x by delta u is e to the negative x cos y over cos 2y. Then delta x by delta v is going to be delta x by delta v. We have e to the x over cos 2y. Then we have delta y by delta u is e to the negative x sine y over cos 2y. And then delta y by delta v is e to the x cos y over cos 2y. So, given the information there, it's a lot less work than in the previous video, where we found these derivatives without using the Jacobian. Alright, so I will see you in the next video.